order of business to recognize Mr. Murphy for 5 minutes.
Thank you, Madam Chairman. Thank you, gentlemen, for coming this afternoon. My expertise for the weather is looking up and seeing whether I need an umbrella or not, so thank you for giving me a heads up on that. Just one actually really kind of rudimentary question. Can someone just explain to me in terms that I might understand the difference between the European models and the American models? In other words, why do we, when I look at hurricanes, I live in eastern North Carolina, so we love to do the hurricane watch. And we see the American models doing one thing and then the European models doing another thing. What's the fundamental difference between those two models?
So I'm going to try to answer this real fast and then hand it over to the rest of the panel. But the primary fundamental difference is how the European Center does data assimilation. And that's basically how they generate the initial conditions in the model. They use a true, what we call four-dimensional variational data assimilation. And right now, the NOAA modeling system uses a four-dimensional ensemble variational assimilation, but it's not they don't truly vary time as the fourth dimension.
Is he being truthful?
Yes, so the principles, the fundamental equations are the same. The way these models are implemented are quite different, like car models can be quite different, although the principle of a car is the same. So in terms of the data assimilation, there's definitely a lot of emphasis in Europe on the algorithms and the use of additional instruments and more data. So that translates into actually additional forecast skill.
All right, thank you. One other question, just in my field, just in medicine, we look forward to every new advancement and what things are going to happen. But I will ask this question, and this is an honest, hard question. What is going to be our ROI on this? In other words, where are we now, stagnant now, and if EPIC is fully instituted, how much further, how much more advanced do we truly, honestly, expect to be? In other words, what can we gain from this in implementing this system? Yes, sir, Dr. Mass.
Well, there's no reason to think the European Center is as good as we can be. American research capabilities so far exceed that of Europe as an aggregate. So our skill can be better than that. I think we could catch up within years if we just got the data assimilation right, and then over a longer period of time improve physics. I think we could be ahead of them in 3 to 4 years if we really put the energies into it.
All right, just a follow-up question, because I'm a function over form kind of guy. When we have hurricanes coming towards the East Coast, everybody acts the same. They buy their water, they get their bread. How is this going to make it any different? Again, I'm just looking, I believe in research. I believe in the advancement of knowledge by all means. But how is it going to change the lives of the average American, say, on the East Coast with hurricanes?
All people make decisions in all types of weather events, whether or not it's a hurricane or a more mundane thunderstorm in the afternoon. Anytime you can make better decisions because you have better information, you're better off. There are estimates that the national economy is in the order of $1 trillion dependent on weather. And if by incrementally improving our weather forecast, if we can make that dependency down by, say, just 1%, that alone is a $10 billion payoff for our economy. I think that's the ROI that you asked for.
All right, thank you. Chairman, I'll yield back my time.